So for this next section, I want to talk about collision velocity and use a really simple example to demonstrate what that's doing. So here I have a box. That box is filled with density right here. So smoke will come out of here. And then I have another box down here that is going to be our collision volume. And I've animated this box so that it goes upwards like that. Now thus far I've only shown you the collision field. So we have a distance VDB called colliz. I've added a few exterior and interior band voxels. And so I'll show you why I did that here in a second. But basically we go in here, we highlight the smoke objects, we have collision checked on, and as we go forward, there is our box down here, the collision box. There's our smoke, it comes down, and as you can see, it's not quite behaving properly. We have some smoke that's going through the object for one, and on top of that, it's not really bouncing off of that surface at all. It should be rolling around this box. And so this is the problem that collision velocity will solve for you. Collision velocity figures out the motion, or I guess the velocity, that the surface points are going in for the collision object. So I'll say that again. Collision velocity is taking the velocity of the collider, and it's telling the smoke to look at that velocity and collide properly. So, long story short, if we want collision velocity, the easiest way to do that is to go to the VDB from polygons where we created our initial SDF right here. We'll create another surface attributes, and we're going to use point.v. So we'll take point velocity, which I've generated with this trail, so compute velocity, and that's going to keep track of the velocity of the points as it moves with the box. Okay, so we have that. If we middle mouse, we have v, it's a vector 3. We can also change this to displacement, velocity, acceleration right there. And let's rename this to our colliz vel. Okay. So now if we go to our collision source right here, and let's just go ahead and go with the preset that we have. Colliz is the original SDF volume, and colliz vel is going to be the source volume over here for the collision velocity. So now if I go forward and I play these frames, you'll notice that that collision velocity is going to push those voxels up more and cause it to roll around the box. We still have some of the voxels making its way through, but this is behaving much more naturally than it was before, and that's what collision velocity will help you approximate. In this situation, if we go to our colliz vel and we turn this up to about 3, that's going to be what we need to really see this behave properly. So we have that, it pushes those voxels up along with the animation of the collider, and this now behaves much, much better. Now we still have an issue with this collider because some of those voxels are making its way through. We can see it right here with these little voxels down here. And there's a great way of fixing that, and it has to do with understanding what the exterior, interior, and fill interior options are on this VDB from polygons. So if you don't know what this means, then here's the way you can visualize it. Let's take a volume slice. I have this going from, let's say, -1 to 1, and let's change this to two-tone so we can easily see what's going on. And if I start playing around with the exterior and interior band voxels, notice how I'm essentially creating a bit of padding away from the surface. So if we take a look, D for display, at, let's say, a marker here that we call density. That density, by the way, correlates with the attributes generated right here, density. We can zoom in, see that this is a value of 0.2. We're getting closer towards 0, and then within the interior, we now have negative values. So it's like a way of feathering out these values inside of here. And what's happening is that we only start really gaining heavier negative values once we start reaching the center. And so let's go ahead and turn off this marker again. if I play around with the interior band voxels, I'm essentially creating that gradient of higher negative values, or I guess lower negative values, towards the center of the SDF. Exterior band voxels, again, it kind of feathers this out away from 0. Now, watch what happens when I say fill interior. If I say that, I only have the exterior band voxels, and if we go ahead and show our marker for density again, we now just basically max out this negative gradient going towards the center. So, long story short, we can say fill interior, or we can turn up our interior band voxels all the way until we've maxed out these negative values. And that's going to cause these collisions to behave better because it's reaching heavier values, which will in turn push it up towards the surface better. Before, what was happening is that if we had, let's say, a value like this, negative 0.1, when it goes to collide, it's only going to, let's say, push the smoke back upwards, let's say 0.1, and it never makes its way back to the surface. When we max out these values to, let's say, 0.3, it'll take a voxel value and max it out back to the surface. So, that's just really good information to know about these collision volumes. In this case, saying fill interior is the best thing to do. So we'll do that, and we'll give ourselves just a little bit of exterior band voxels right here as well. And that ought to do the trick for us. Now let's go back here, go forward a few frames, and see what that did. And sure enough, it fixed that leaking issue. So now we don't have those voxels peeking through anymore. Okay, so now that you understand what this does, in the next video, let's go ahead and create the collision field as well as the collision veil field for our overall simulation.